So hello everyone. So today we are going to discuss the problem array description. So what we are going to cover, the first we see the what is the problem. Then we discuss why we are not going to use brute force. Then how to think in DP direction. Then what's the approach. Then how to write transition state. Then we define the base case. Then we discuss the code. Okay. So this is the flow of the video. So let's discuss the first thing, that is the problem. So you know that an array has an integer n and integers between 1 to n, and the absolute difference between two adjacent values is at most 1. So what it means to say that you have an array, right, of n integers. The value of these elements can be from 1 to n, right? For a given description of the array where some values may be unknown, maybe some values may be unknown, your task is to count the number of arrays that match the description. Okay, so let's discuss this test case, right? We have n equals to 3, m value can be m value is 5, and we have array 202, right? This is the array. So the elements, the value of the elements in the of the array is between from 1 to 5, right? So this is the unknown value. The 0 represents the unknown value, unknown value. So what you are going to choose for this position, right? How many options you can have? You can have 1, 2, 3, 4, 5, right? So you can choose one, right? You can choose one, right? If you choose one, the array becomes 212, and you can find that, and you can find that the difference between the adjacent elements is at most 1. So the difference between is 1. So the difference between these two is 1. We have to take the absolute difference, right? So if you are going to choose 2, so the array becomes like that, and you found that the adjacent element, the difference between the adjacent element is going to be at most 1. Now, if you can choose, you can choose 3 also, 2, 3, 2. In this case, the description, this array matches the description, right? That is uh, the value of unknown element is between 1 to 5, and the absolute difference between two adjacent element is 1, is at most 1, right? Here, at most 1, that is you can have the difference 0 or 1. You can have the difference 0 or 1, but you cannot take 4 because the difference between the adjacent element is 2. This is not possible. Why? Because the at most difference has to be 1, right? So for this, the number of arrays you can have is 3. So the answer is 3, right? So this is the problem. I hope you got. I hope you understood that what is the problem, right? Now let's see why we cannot apply brute force. So you can see that the constraint n value can be from 10 to 1 to the maximum n value can be 10 raised to the power 5, and the m value is 100. So in the worst case, in the worst case, in the worst case, you can have n elements with zeros. So you have to try out all possibilities. You have to try out all possibilities. So the time complexity is going to be 10 m raised to the power n, m raised to the power n, which is something that is very big, large number, right? This is something which is very big. So we are not supposed to do this, right? Now what we can do, what we can do, we have to find that is there any sub problem? Is there any sub problem? Yes, it is. Let me show you. Suppose this is the example, right? This is the example. M value is 3, and 1, 2, 3, 4, 5. N value is 5, right? Now, for suppose you have to fill for this position, you have three options. You have three options that it can have the value from 1 to 3. It can have the value from 1 to 3, right? So the possible arrays can be 2, 1. Let me write it with a different color. The possible array can be 2, 1, 0, 0, 2, right? Or it can be 2, 2, 0, 0, 2, or 2, 3, 0, 0, 2, right? Now you have to solve for this. You have to solve for this. You have to solve for this, right? Now let's take one by one. You have to solve for 1, 0, 0, 2, right? Uh, what are the possibilities? That you can have 1, you can have 2, you can have 3, right? You can fill this position by 1, that the difference between the adjacent element is 0. So this is possible. Now if you're going to take 2, This is also correct. If you're going to take 3, this is not correct. You cannot take 3. So for this, there are two possibilities that you can take 2, 1, 1, 0, 2, or you can take 2, 1, 2, 0, 2, right? You can take 2, 1, 0. These are the two possibilities. Now, so let's solve for the second one, right? 2, 2, 0, 0, 2. Now, for this, you can have 1, you can take 2, you can take 3, any one of them. Now, if you are going to take 1 or 2, either of them, the problem reduces to this, right? The problem reduces to this, right? Suppose for this, the resultant array can be 2, 2, 2, 2, or 1, 0, 2. For this, 2, 2, 2, 0, 2, or 2, 2, 3, 0, 2. So you can see that you have this array and you have this array. Now these are the similar problems. These are the similar problems, right? For this, you have the choices, right? That is 1, 2, 3. For this, you have also choices 1, 2, 3, right? So you can take either of them, 1, 2, 3. So you have to add the number of arrays that matches the description, right? You count the number of arrays that matches the description and you add up to your answer. So these are the similar problems. So we found that there are sub problems in there. There are sub problems, right? So we are definitely going to use the dynamic programming to solve it, right? Now let's see what's the approach we are going to use to solve this, right? So suppose you have array, something like, right, you have array, and suppose this is index I. This is index I, right? You have to fill index I. Okay. So for, so whatever you filled here, that there are some constraint introduced for index I minus one, right? What it means to that, suppose you have 202,003. So you filled m value is 5. So you filled it with suppose 2. So what are the choices for this? If you filled it with 2 and suppose you filled it with 3, what are the choices for this? So you the choices is you can fill it with 1, you can fill it with 2, or you can fill it with 3. Now if you filled it with 3, so the choices are changes, right? The choices are changes that you can take 2, you can take 3, you can take 4, right? So whatever you choose here, suppose you choose x element here, right? So the constraint introduced on I minus 1 such that I minus 1 element can be x minus 1, x, or x plus 1, right? Right? To make the array such that it matches the description. So if you gonna choose element x here, so the possible choices for this can be x minus 1, x, or x plus 1, right? Agreed? Now, suppose now with the help of this, let's try to write the transition state. Suppose dp of ij, what dp of ij represent? It represent, let me write it here, dp of ij, what it represents. So it represents the number of arrays, the number of arrays, the number of arrays of length I, of length I, of length I, of length I, such that the last element is x. This is the dp of ij represents. Okay. So if you're going to choose j, so there are uh, there are possibilities that uh, there are possibilities that the previous element is going to be the previous element is going to be j minus 1, or the previous element is going to be j, or previous element can be j plus 1, right? So let me write it. So for a dp of ij, for ij, you are going to look at the three subproblems. That is f of I minus 1 j minus 1, f of I minus 1 j, or f of I minus 1 j plus 1, right? These are the three subproblems. So your DP state can be like that. The DP of ij equals to the sum of all of these. The sum of all of these. The number of arrays to produce the number of arrays that matches the description such that the last element is j minus 1. The number of arrays that matches the description such that the element is j. The number of arrays that matches the description such that the last element is j plus 1. So you have to add all of them. So it is equals to the number of arrays, right? If you're going to choose j minus 1 plus with the number of arrays, if you are going to choose j, the number of arrays, if you are going to choose j plus 1. So these are the this is the transition state. This is the transition state, or we can see that recurrence relation, right? Okay, so this is our transition state. So now let's define the base case. What can be the base case? Base case. So there is a case when you reach at the 0, I minus 1, that is you reach at the 0, right? So for the 0th element, what what can be the state, right? What can be the state? So there are two cases. The first element is 0 itself. The first element is 0 itself, or the first element is some element, suppose x, or we can say that there is some element e, right? So here you can see that there is element 0 in the first index and there is element 2 in the first index, right? Or if it is 0 based indexing, that is at the 0th index. So if it is 0, you can choose any, you can choose anything from 1 to m, 1, 2, 3 up till m, right? So whatever you make, whatever you choose, the number of arrays up till up till length 1, up till length 1 is going to be 1 for all the choices, right? For all the choices. That But it means that if you're going to choose 1, the number of arrays up till 1 is going to be 1 if you choose 1, right? If you choose 2, so the number of arrays is also 1 for that. Of the number of arrays that matches the description is also going to be 1, right? The number of arrays, if you choose any one of them, the number of arrays of length 1 is 1, right? Is 1 that matches the description, that is the this array itself, right? So what you can feel that if it is 0, so for the index 1, you have to look at the I minus 1. You look at the 0, that is a I minus 1, a I minus. So suppose this is the base case, right? So we have to fill dp of 1, dp of 1 0, right? dp of 1 I equals to 1, equals to 1, right? For all 1 to m, right? If you choose 1, suppose this value is the value is m, so this represents a j and this represents a I. So from 1 to m, from 1 to m, you are going to fill it with, for if you choose 1, the possible arrays of length 1 is 1. If you choose 2, the possible arrays of length 1, if you choose 2, is 1. So this is how you can fill. Now if it is the element, if there is some element, so base case is going to be for that element the number of arrays, for that element dp of 1, for that element the number of arrays is 1, right? For that element the number of arrays is 1. Why? Because you are not going to, you have not any choices, so with you have to fill with that number, right? So up to length 1, if you choose 2, so there is only one possible array. This is the base case. So what you have to do, that dp of 1 I equals to 1 if it is 0, or if there is an element, so you have to put dp of I equals to 1. So if there is 0, so you have to fill it with 1 for every 1 to I, 1 to m. And if it is not, so for that element you have to fill it with 1, right? For that element you have to fill it with 1. So this is the base case, right? If there is element, for that element the number of possible array that matches the description is 1. If it is 0, so if you're going to choose 1, the number of possible arrays for that chosen element is going to be 1, right? Of length I, that is of length 1, right? So now let's see. Now so this is the transition, this is the base case. Once there are some things that you have to care about, that for 2, you have to look at the previous, right? You have to look at the I minus 1. So suppose this is 2. This is second element. You have to look at the a minus 1. A I minus 1 equals to 2, right? A minus 1 equals to 2. So if it is the element, then you have to fill it. Then you have to fill it, right? If it is the, because there is, if for 3 you are not going to fill it with, right? Why? Because there is some other element. You cannot choose 3 because there is some other element that is 2 already present, right? So for 3 you are not going to fill it. Filled. So if it is 0, if a minus 1 is 0, or a minus 1 is not equal to j, is not equal to j, so then you are going to, this is j and this is I, right? So so if it is not 0, or if it is not equal to j, the number itself, then you are not going to fill it. So for that, the dpij is going to be 0, right? So if there is 2, so you have to fill for 2. You have to fill for 2. Why? Because they, you cannot fill for 3 because there is some other element that is 2 already present. You cannot fill for 4 because there is some other element that is already present. Now if it is 0, if it is 0, you have to fill for 1, you have to fill for 2, you have to fill for 3, you have to fill for 4, you have to fill for 5, right? You have to make choices if it is 0. If it is the element, so you have to fill only for that element because there is for, if for 2, 3, 4 there is already element present, so you cannot make choices, right? Now if it is so this is the so this is the transition that you can make, right? So you can see that we filled with the base case. Then for this you have to look at the I minus 1. You have to look at the I minus 1. For this you have to, for this you have to look for the I minus 1, right? That is the this row. And you have to, you can fill it with j minus 1, j or j plus 1, or you have to add all of this. So the answer for this is 3. That is 1 plus 1 plus 3, right? So for this you have to look at the j minus 1, j or j plus 1, right? Now one thing you have to note that the j minus 1 should be in bound, right? Uh, then you're going to fill it. So you can, what you can see that j minus 1 should be greater than equal to 1, or j plus 1 should be less than equal to m, right? For the description say that the element can be from 1 to m. So you have to make the condition that it is not out of bound, right? So you have to maintain the foundation that if you are going to take j minus 1, right? So it has to be greater than equal to 1. J minus 1 has to be greater than equal to 1, and j plus 1 should be less than equal to 1, right? So you have to ensure that, right? Suppose you are at the 5 and you are going to look at j plus 1, that is 6. So this is not the case, right? So this is how you can fill your DP table. So I hope you got the intuition. What will be the answer, right? What will be the answer? So the answer is the summation of all of this, right? That for the one, what will be the number of possible arrays if you are going, if you have the choices 1, right? You filled it, you filled the last, right? Right. So the answer is going to be dp of n1, dp of n2 plus में up to dp of nm. So this will be the answer. Okay. So now let's try to code it. So let's try to code it. We have n number of elements and the value can be from 1 to n. 1 to n. So take the input c n m, define the vector array of size n, and take the input. Yes, this is the input, right? Now next we have to define our dp vector. Vector of int dp of size n plus 1 comma vector of int m plus 1 comma 0. So this is our dp vector, right? Now the next thing we have to define, that is our base case, right? Base case. So what will be the base case? Base case. So for int I equals to 0, int I equals to 0, I equals to 1, I less than equal to m, I plus plus, if a0 is equals to 0, or a0 is equals to the element itself, then we have to fill it with 1, right? What it means that if the element is 0 or the element is itself, so the number of arrays that matches the description of length 1, if we choose I, is 1, right? What's dpij represent? What's dpij represent? The number of arrays, the number of arrays of length I, of length I, of length I that matches the description that matches the description such that such that the last the last element is j, right? So this is what dpij represents. Okay, this is what dpij represents. So next thing we have to fill for I equals to 2 of length I up to length n. So we filled it for the length 1. Next we are going to fill for the length 2, for the length 3, up till the length n, right? What are the choices can you make? You have choices from j less than equal to 1, j plus plus, from 1 to n. Now if the array of if the previous element is not equals to 0, and if the previous element is not equal to the element itself, then you cannot have any choice, right? If it is not equal to 0, that there is some element and you have to fill for this element. Otherwise there is, if you're going to fill for the, suppose you have to fill for 2, the element is 2, then for 3 you are not going to fill, right? You are not going to fill because there is some other element that is 2, that we saw in the lecture, right? So for this the dp of ij is equals to 0, right? Now next thing what we can do, if it is equals to 0, if it is the element itself, then we are going to fill it. So dp of ij is equals to, what will be the transition? Dp of ij plus, let me write it in a general. So let's say you have the choices, that is j minus 1, k less than equal to j plus 1, k plus plus. So you have choices, that is j minus 1, j, or j plus 1. These are the choices that you can have, right? I generalized it in a loop. So dp of ij, when you are going to take, when you are going to fill, if it is in the boundary, right? if k if k is greater than equal to 1, and k is lesser than equal to m, then you are going to fill it, right? So what will be the transition? Dp of ij equals to dp of I j plus dp of I minus 1 and the k, right? You have to take the mode, percent mode. So this is the transition that you can make. What it means, that if you're going to choose j minus 1, so if you're going to choose j minus 1, right, then how many number of arrays of length I minus 1 you have to add it for the length of I, right? If you're going to choose j, if you're going to choose j, right? So you can have choices, that is j minus 1. So how many number of you have the choices of j minus 1, so how many number of arrays of length I minus 1 you have to add for length I, such that you choose j, right? Now next thing, we have to construct our answer. What will be the answer? So we have to construct our answer. So let's initialize our answer. So for int I equals to 1, I less than equal to m, I plus plus, the answer equals to answer plus dp of n I. Let's take the mode, percent mode, right? And then you have to just see out the answer, right? Now how this answer is constructed. Now what it means, that how many number of arrays of length n, such that the previous element is I, such that the last element is I, not previous, it is the last element, right? So you can have choices for the last element, that is you have choices for 1, you have choices for 1 to n. So if you are going to choose, if the last element is 1, so how many number of arrays of length n? If the last element is 2, so how many number of arrays of length n? You have to add up, you have to add up all these arrays, right? So this is the code. Let me go through once again. So these are the input that you take, right? Next you define your dp vector. Dp of ij represents the number of arrays of length I that matches the description, such that the last element is j, right? Such that the last element is j, right? Now for you filled you define the base case, that if the first element is going to be 0, or if the element is itself, so you fill it with 1, right? Then you have to find for length up to 2 to n. You filled it already for the length 1. So you have for the last element you have choices from 1 to n. If you're going to choose j, if the last element is j, so how many number of arrays that you can have of length I minus 1, you have to add it up for the length I, right? And finally you make your answer, that how many number of arrays of length n such that the last element is I, right? So this is the code. So let me check if there is any type of mistake or not. Right? Yes, this is correct. This is also perfect. Yes, this is also perfect. Less than equal to. It has to be less than equal to. Right? And this is also perfect. 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 Right? So let's try to run it. Let's try to run it. Yes. So the number of arrays is three. Are three. Right? So let me print TP table for just understanding. I less than equal to n I plus plus for int j equals to 0, j less than equal to m, j plus plus. C out dp of I j, right? C out and C out and yes. So let's try to print it. So we have to take it j here. This is j. Yes. So this is our dp table. So this is our dp table, right? So you fill for this you filled it with one, right? This is the 0 1 2. This is the 2th column and you filled it with one, right? You filled it with one. That is the this, right? If a0 equals to 0 is equals to I, that is 2, right? So you filled it with one. That is up till for this the number of array, right? The number of array is one, right? Of length one, such that it matches the description, right? If the last element is 2. Now you have to fill you this is 0, right? So you filled it. This is 0. So if it is 0, right? So you have to fill for the j minus 1, j plus 1, k plus 1. So for this, for 1, you look at this, you look at this one and you look at this one. So you add it up, right? You add it up and the answer for this is 1. Similarly for this, the answer is 1. Similarly for this, the answer is 1. Now for this one, you have to look at this one, you have to look at this one, and you have to look at this one. So you add all of these, the answer is 0. So this is how you filled. Now for 2 you are going to fill it with 3. You are going to fill it with 3, right? So this is how you do your transition. So let's discuss the time complexity. Let's discuss the time complexity. So the time complexity is going to be n cross n, right? The time complexity is going to be n cross n, n cross n, right? N cross n. And the space you are using the 2D vector, that is n plus 1 cross n plus 1. So this is a code, right? I hope you got, I hope you understood, right? Thank you.
Until we reach it, all you need to know